Well, thank you for everyone for joining us again for our third day of Stormwater Awareness Week. We have TJ here with us. He presented yesterday on TMDLs, and he has another great presentation today. But with that, I'll just pass it along over to TJ.
Awesome. Thanks. And yeah, thanks everyone who showed up. And if there are some of you who were here yesterday, I guess you'll get a little repeat introduction here, but because I think I see a couple new faces as well. So let me get my screen shared here. Oops, it says host disabled screen sharing. You can take a quick look at that.
There you go. Should be okay now.
Okay, there we go. Yep, perfect. Ooh, that was close. All right. See everything okay?
Yeah, it's coming through.
Excellent. Okay, well then I will get started. So hello everyone. My name is TJ Mothersbaugh. I'm Business Development Manager for Water Tectonics. Been here for about 12 years and like you mentioned, work in a lot of areas in water treatment and stormwater and other contaminated water applications. I'll give you a little background on our company, and then the majority of today's talk will focus on PFAS issues. Specifically in California, but also I think there's a lot of content in here that's generally applicable if it's something you're interested in. So I'll do a little background on PFAS if you're kind of new to the topic. Some of the regulations around it that are current and developing. What that relevance is to stormwater, since this is Stormwater Awareness Week. Talk about some of the challenges in sampling for or analyzing PFAS compounds, and then get into the treatment options and some work that we've done. So yeah, Water Tectonics, been around since '99. We design, manufacture, install water treatment systems, across the U.S. And internationally as well. We do wide range of treatments, from simple stuff to fancy stuff, but mostly pump and treat, multi-step kind of processes, designed with, site-specific conditions and water quality goals in mind. We have an in-house design engineering, lab R&D team that helps with, proper technology selection, treatability testing, pilot testing, all the things that you'd want to do in advance of a project to validate an approach and do good diligence. And then we have a field service team that comes out and installs systems, trains folks how to operate them, provides service on an ongoing basis for the life of that system. In terms of the types of treatments we're talking about, these would be kind of the main ones. So things like pH adjustment, chemical treatment, clarification, filtration, ion exchange, membrane, electrochemical, disinfection, biological. So it's a kind of a wide range of things. And then I'd say also, integration of these different steps, forwards and backwards, right? So someone may come to us and say, hey, I need a system that adjusts pH and settles and filters it, then runs it through an ion exchange and membrane step. And I want all of those processes in a single box on a single control screen and have it function as one system, right? So that kind of bespoke custom manufacturing is a lot of what we do. Some of our work in California, worked pretty well across the state now. Our first project was in 2004 in San Francisco at the port. Long ways back, and have done a lot since then. Probably most of our early work was focused in Bay Area, and in the last kind of 5 years or so, have gotten more into the LA and SoCal area, as well as some of the Central Valley area there. So most of these are stormwater projects, but some of them do have PFAS issues here. Some of the other projects I'll be talking about are PFAS projects elsewhere in the country. All right, so introduction to PFAS. PFAS as a group, well, I guess I should, talk about the acronym per and poly-fluoroalkyl substances, right? So this is a class of compounds. They're man-made. They've been in use since the 1940s. You can hit this link at the EPA and see all of the EPA's master list, right? There's over 5,000 identified compounds that are in this class of compounds. These carbon, fluorine, primarily based compounds. So there's a lot when you talk about PFAS, right? You have to look at when you're talking about the specific PFAS one that you're concerned with. The primary use here has been in non-stick coatings and firefighting foams, right? There's other things too, but I'd say these are the two biggest sources. So you've got, one where fires have been put out, right? And potential contamination from those foams into groundwater supplies. And then you also have the manufacturing locations for these products as major sources as well, right? So where they're manufacturing Teflon or Gore-Tex, or where they're manufacturing the firefighting foams, et cetera. Number of human health risks. Let's see here, I've got a couple things in the chat. I just want to, is anyone having any issues there, Danny, or were you okay? Just some questions coming.
Everything looks good. Someone said on, will you be sharing the slide deck after the workshop?
Yes, happy to. And I think, isn't it going to be recorded as well?
Yeah, so for everyone in the chat here, by the way, feel free to chime in with questions. You can unmute yourself if you'd like to ask TJ a question, or if you want, you can type it in the chat. And as TJ mentioned, this is all going to be recorded, and it's going to be on our YouTube channel for Forge, and also on our Forge website for free for you to access for everyone here.
Yeah. The little chat notifications don't really show up too well in my view here. So Danny, if you see someone with a question that would be good to address in the moment, just interrupt me, and I'll try and take some pauses as we go too. So
yeah, and we actually have.
Nope. I lost you there. Did you have something to say there?
Go ahead, TJ. This is John
Yeah.
Broskis. I don't know. I think Danny's having a technical problem, but you're still streaming, so go ahead.
Okay. All right. We'll just continue on here, and we'll make sure to get to all those questions here at the end. So, great. So yeah, the kind of the main sources there that we just discussed. There's you could have a whole presentation on some of the human health risk concerns right around PFAS, but number of acute and chronic exposure concerns here with these chemicals in drinking water supplies, and exposure for personnel who work in these areas. And so that ultimately led to their production phase out in the U.S. Number of years ago, and focus is really now on cleanup. These compounds are still manufactured in other places in the world and have actually ramped up, right, as the U.S. has kind of backed off from these compounds. There's replacement compounds that have replaced kind of the main ones of concern, and then there's also concern about those replacement compounds as well. So I'd say it's still an evolving and ongoing issue, right, that we're trying to figure out. Part of the benefit of these things is that they're very good at what they do, right? I mean, that's it's part of why they're so persistent in the environment as well, right? So we'll get into that chemistry though here. And I'd say significant legal, monetary, action around these issues currently and still coming, right? So, last year there was a, Mark Ruffalo movie, Dark Waters, on this topic, very well regarded movie, tells a great story. There's recent settlements, in the approaching the billions, and many other settlements that are going to likely be above the billions, right? And these are for, here, this Minnesota versus 3M, this is for $720 million just for, the Eastern Twin Cities area, right? There's another one with DuPont for, $900 million in Ohio West Valley area. So there's a lot of things in this if you track the news on it. So.
Hey, TJ, so there
Yes.
actually was one question. It says, the Dark Waters movie was useful for introducing me to this topic. Do you, TJ, see that is a pretty good way of capturing the issue? At least for the film.
Honestly, I've not seen it yet, so it's on my watch list. So I cannot provide any commentary on that. I've apparently been too focused on work to pick it up yet. But I'm looking forward to watching it. It's on my watch list. So, All right, so just some of the hot spots. There's a lot of different resources out there that looking to start mapping these items. I'd say they kind of break them up into kind of military, drinking water, and other kind of sites where there's usually manufacturing or significant contamination for other reasons. Yeah, I included a link here, so you can kind of dig into the specific data. You can see really a lot of it concentrated on East Coast, because I think a lot of the product manufacturing, right, for these compounds of interest kind of took place along this band. But there's not insignificant sites here, in the West as well. So when we talk about the chemistry of these compounds, what do they look like? Why are they a concern? What's challenging about them? I think it just helps to have a little bit of that sense. So these are kind of the two main ones where most of the regulations are focused right now, which is PFAS and PFOA. PFOS standing for perfluorooctane sulfonic acid, and PFOA is the perfluorooctanoic acid. They have these long carbon fluorine bond chains, and then which they call the tail, and then they have these different little head groups here, right? And this bond right here, one of the strongest bonds in nature, this carbon fluorine bond, and this whole area, very hydrophobic and just very, these properties make it very water soluble and make it very persistent to degradation or breaking down. So it stays in the water, it's very soluble, it moves very quickly through groundwater, things like that, right? These are some of the things that make it challenging. And then I included this list over here. I'd say these are, probably the top 15 or so that normally get attention, depending on where you're at and what folks are interested in, right? There's 5,000 of these things that you could look at. So there's a lot, but these are probably the main ones. So regulations in California. So regulations in general in the country, right? There is guidance from EPA. I'd say there's rulemaking being developed. There's a bill that passed out of the House that hasn't been taken up by the Senate, but there's really not a national federal regulatory guidance yet, right? And so, or at least a lot of the action is being led at the state level for the specific regulations currently, using the tools of MCLs, maximum contaminant levels for drinking water. They have non-enforceable guidelines, action levels, different sorts of definition tools there. But really, I think people are in the phase of, let's start identifying sources. Let's start developing, criteria for when and where we need to take action, right? And these are the kind of the tools that they're trying to use that by. This map here on the right is a map. You can get a link here to the Water Board's website for some of the main areas they're focusing on currently, right? So I'd say that the top three, you've got the chrome plating facilities, airports, landfills, military, and treatment plants. So all sorts of data, right? And then this is just the Water Board's main PFAS landing page. There's a ton of work they're doing in this area, right? And investigation and identifying and characterizing. So in February of this year, they updated their response levels, or RLs, for drinking water to 10 part per trillion for PFOA, 40 part per trillion for PFOS, and we're talking trillion there, right? So not billion or million, we're talking 0.000001 ppm. So pretty low levels, right? That you're looking at where these things are a concern. Most of the concern, right, is drinking water, right? It's human health, it's human contact. That's where the concern is. But things are starting to creep into the stormwater side as well. So we've done, I'll highlight a couple projects here at the end, but in cases where stormwater could be contaminating groundwater, right? Or could be discharging to, there are also, concerns about if we should be concerned about these things in the marine environment as well, right? And what's the risk to fish health and other things too. we're a long ways away, I would say, from any sort of broad regulation of these compounds in a stormwater environment. But I think there will continue to be a lot of attention and a lot of case by case, focused attention by the water board and others on hot spots, right, for these compounds and where they may show up. So, and here's your, sense of where to focus first, right? This is where they're focusing, and that's where I would focus as well if you're concerned or interested in that space. So. Okay. So on to some other topics here. So sampling for PFAS, right? When you're talking about anything in the part per trillion range, sampling technique methods, even more important than you might be used to for other parameters in the part per million range. I'd say this guidance varies significantly, and people are sometimes a little divided on how strict you need to be. Some of that depends on, what legal situation folks are in, how many of the different PFAS compounds they're looking at, what detection levels and methods they're using in their analysis. So, but I'd say these are probably the most common ones, right? So, one, you look at not using certain types of materials, anywhere in your sampling kits, right? So the bottles that you're using, if you're using, funnels, if you're using coolers or any different materials, just making sure you keep those away from, or really don't use them, right, when doing your sampling. So, and then the ones that would be recommended. Even things like the types of writing implements and utensils. So, again, waterproof anything is a no-no, which is tough in stormwater, right? We always want to go out there in our Gore-Tex or our Tyvek and have that. So, things like sticky notes, hard spiral bound notebooks, all these things, all those coatings on that material all has that risk there. So recommend just kind of loose paper, clipboards, again, markers versus pens, chemical ice packs versus bags of ice, and really anything kind of waterproof, stain treated clothing. Just say, hey, cotton. And, this was even from a Department of Defense site I went on to. They said, all of the cotton clothing you wear needs to be laundered a minimum of 6 times from date of purchase and cannot have used any fabric softener, right? So very, very specific. I mean, there was, I think, 2 to 3 pages of guidance for, how to do the sampling. So even if your sampling is perfect, you still have a risk for contamination, at the lab is always possible. So, making sure that the lab you're working with is, understanding what your goal is here, right? They have good methods and controls in place to prevent that, because we are at such low detection limit levels. That's really important. If this is something you're going to be doing on a chronic basis, right, you probably want to do some real good diligence on the lab you're working with and have them walk you through their procedures, right? For keeping, at a minimum, I'll see things like, PFAS receiving areas, are separated from, non-PFAS sample receiving areas. That should be, at a minimum. Coolers labeled separately and things like that. On the analysis, depending on which PFAS compounds you're looking for, what test methods you're using, what else is in the water, this analysis can be, pretty complex and expensive. I've seen a lot of great presentations from folks who work just on the lab side of this, with, 50 slide presentations on the challenges. It's not easy stuff, and it can be, hundreds to, many thousands of dollars, per test, depending on the sample. And just for scale, right, 1 part per trillion is like 1 drop of water in an Olympic pool. And you're not just looking for any 1 drop, but a specific kind of drop, and assuming the pool is dirty, So, I mean, that's kind of the investigative work that, the labs are doing when they're trying to do this sort of analysis. So treatment options. I'd say in some ways this is kind of the good answer here, right? Is that treatment options in some ways are widely available and work pretty well. But they are case specific. You know, it often requires kind of multi-stage, often requires a good amount of pre-treatment. I'll kind of showcase some of the pros and cons and use cases for different ones over the other. But, you know, at minimum, things like, you know, solids and oils and other metals and other organic contaminants or bacteria, right, will probably need to be out of there. Your selection is probably going to be based on, you know, what's your influent loading of your PFAS, your effluent target, what other contaminants are present, what's the total volume we're talking about treating. Is this, you know, a little small flow or a large flow? Is it intermittent? Is it 24/7? And what are you going to do with the waste? That's another big one. We're talking, you know, when you're talking about removing the PFAS, it's going somewhere, right? Whether it's going into a solid sludge or a liquid waste stream, that has to ultimately be disposed of somehow. And depending on what your options are for that, can really drive the economics of your choice here. So. All right, this is kind of the bulk of the treatment options section. 4 main treatments, I'd say, and there's other things, you know, these aren't the only ones, but these are the 4 that I would say are the most mature, have the most data, most widely in use. And there's another, you know, 4 to 5 behind this that are, you know, in development in various stages of R&D that folks are interested in. So the first one, carbon, granular activated carbon, right? We use it in so many areas in water treatment, and luckily it works well on PFAS too, right? So it's just the amazing Swiss Army knife of the water treatment world. You know, you do need some pre-treatment, maybe not as much as some of your other steps, but you need, you know, relatively solids to be pretty low in the water, and you don't want a lot of other organic foulants in there. You want this surface area in your carbon to be able to do its job in grabbing onto the PFAS. So in terms of the removal mechanism here that we're talking about for the carbon, so tail adsorption. So if I go back to what those PFAS compounds look like, what I'm trying to do with the carbon is to get this tail here, this hydrophobic tail, to stick to those carbon beads, carbon media in that vessel when I treat it. For carbon, you know, depending on the loading and application, you know, you could potentially regenerate the media, you know, or you may send it off for incineration. Modeling wise, in terms of kind of predicting, hey, how much is this going to cost me? How much carbon am I going to need? Can't really software model it. You really need to do bench testing, so getting a sample of your water and running some real tests. And I'll talk in more detail about these 3 items here on these modeling efforts. Okay, next one, ion exchange. So there is a wide range of these are kind of vendor and you know, proprietary media mixes from all sorts of companies. Pre-treatment is high, right? You need to be highly treated water before you're going to send it to here, because, well, one, it's an expensive media, and it's very targeted. You don't want to foul it. So oftentimes in a treatment train, right, we'd even put kind of the carbon in front of the ion exchange and use them both, and that would be our pre-treatment for going to this step. The additional benefit with the ion exchange is that we get to target the tail and the head of the PFOS and PFOA, et cetera, molecules. So we're going to do a better job of getting probably more of those compounds out in an ion exchange step. And, you know, just better overall efficiency. This media is probably going to last longer. But again, you're gonna have to replace it less often, but more expensive. So that's kind of the trade-off here, right? This is your expensive, highly efficient step that you want to really pre-treat well before you get there. There are some cases for regen of this. It's pretty specialty. I've only seen it done in a few cases. You know, we haven't done it, but you know, whether or not it pencils out, I think is going to be really loading specific. You know, how concentrated of PFAS are you talking about? I think probably as you get into really highly concentrated PFAS streams, maybe on-site regeneration of ion exchange is feasible. But in most cases, it's going to be what's called a single use, right? You're going to use it until it's exhausted, and then you're gonna ship it off for incineration. The nice thing about this is you can model it on software, right? We don't need to get a sample. If I can just get, if I have a historical data set, we can plug that into the software model and predict with pretty good accuracy, you know, what the expected life and maintenance here is on the item. On to the next one. So RO, or reverse osmosis, right? Another widely used water treatment technology. Again, very high pretreatment needs. This is a pretty advanced, you know, running an RO system is much more complicated than running a GAC or an IX, which is just a vessel with media in it, right? This is a membrane with some advanced controls. So there's some more complications there. The main method of removal here is size exclusion. So we are, these are the molecular weights of the PFOA and, PFOS, error there in my deck. And our RO is going to screen out things in molecular weight and let's say the 20 to 30 Dalton or range there. So these things being larger than that, that being how RO works, right? They're going to get excluded and sent to the reject stream. The downside here is that we have, you know, a 20 to 30% typically liquid reject stream, depending on what else is in the water. You know, maybe that can get down to 10% or something if it's depending on the other co-contaminants, but I'd say this is common. The nice thing about this, again, we can model that on software. The big downside here is this liquid waste stream. So if we don't have anything to do with that, it's probably more efficient to have our contaminants go into a solid waste in the media than having this liquid waste stream, right? And having to transport that somewhere. Last one here, I'd say this is probably the least widespread of the four, but you know, it's gaining some traction. You know, there's some nice things about this. So it's kind of ozofractionation. Basically, you're using ozone to generate they call micro nanobubbles, and these go into solution and they're super small and they're able to you know, supposedly kind of attract with the PFAS compounds, and then they kind of lift them out of the water phase into this like foam phase where then they get separated from there. The other benefit here is that supposedly you don't need to do as much pretreatment. You can send water that looks pretty dirty and has high PFAS through it. And there is a liquid waste stream though out of this process, like with the RO. So I think of them kind of similarly that way, right? A liquid waste stream versus a solid waste at the end of the process. And I'm really actually not aware of what modeling tools may be available for that in terms of predicting operating costs or other things. But you know, I'd say again, this is kind of the one that's most in development. So, but we are working, you know, with all four of these currently. You know, ourselves and through partners on various projects. So, okay, so a couple things here on modeling, because really when you get into saying, okay, well, there's some options, you know, which one of these should I use? I have a PFAS issue, or I have a site where I need to do something. How do I select, you know, which one's going to technically achieve my goals? So with GAC, you can do two types of studies. First one is called an isotherm study. This is helpful in selecting which type of carbon is going to be the most efficient for your mix of contaminants. It determines the absolute adsorptive capacity, compares those across different media types. That doesn't quite tell you your OPEX, it just tells you which carbon to go with as the best. The other test is what we call a rapid small-scale column test, and this here does predict breakthrough time, and breakthrough time would be, you know, relevant to the operating costs, right? How long does it take before that PFAS is going to break through our media, is going to go through it, right? Is going to be fully uptaked in the bed and is now just passing through. You know, how many bed volumes or how many gallons can that vessel of 2,000 pounds or 5,000 pounds treat before it needs to be removed and replaced? So,
Hey, TJ, so there's another question here.
great.
There's a comment in the question that says, I am shocked that incineration is acceptable for waste streams. Would opacity laws then kick in on incineration waste? Or how is incineration controlled to ensure no airborne PFAS remains?
Yes, yes. Well, so there's, I believe there's like 3 facilities, right, where this is taking place right now, and yes, there is a lot of scrutiny and concern. I think the question is that, well, what else are you going to do? You can break down the bonds. I think it's like, you know, is it 8 or 1200 C? I mean, it has to get pretty hot. And obviously, in any application where you're doing something that, you know, you could risk not perfect air stacks and other things right there, and capturing and breaking down components. So there's risk. People are looking at that. I just think there's not any better options yet. In Washington State, for example, here we just had a program where we rounded up a bunch of old AFFF firefighting foams. Department of Ecology did a analysis really across the country of all the things that they could do with this, you know, many thousands of gallons of foam that they'd collected to destroy. And they said, yeah, our best option is to send it to the main disposal facility here is outside of Salt Lake City, Utah. I believe it's a Clean Harbors facility potentially, out in the middle of the, you know, middle of the Utah desert there, and incinerate it. And that was kind of the conclusion they came to. So again, not my area of expertise in terms of, you know, knowing the air emissions concerns and all that. I hear people raising those concerns. I just also don't know what else you do with it at this point. So, yeah. Okay, and then back to here you know, for both of these tests, though, I would say, you know, these aren't just like straightforward, simple tests. You know, there's a lot of site-specific, method-specific considerations that need to be evaluated when designing and running these tests. So you have to look at your specific water and know what your goals are to get some useful data out of them. But they are good tools. So there's something that you can use to model. Ion exchange. Here, we really only need a data set, right? So if you have a sample, there's about between 20 and 50 items that we'd want analyzed. You know, probably the 20 are really kind of the top key ones. And then if you have some additional, that can help make the data set even more accurate. Most of these are all proprietary, you know, vendor, media specific software modeling programs. So, you know, I collect the data in a table. I hand it to my media vendor and I say, hey, plug this into your model. Tell me what my life's going to be on my media. And they come back with some sort of, you know, curve like this, right? So you got the different compounds here that we were looking at, concerned with, breakthrough times, etc. You can also do the rapid small scale column test here if you want to do that on IX media. And last one, RO modeling. So kind of two different ways I think about this, but one, when I take, as we mentioned with RO, right, you have to do a lot of pretreatment. So I'm going to, you know, treat the water and then either predict or, you know, sample what that effluent from my pretreatment is as my influent to my RO. And I'm going to take that water and plug it into this model and say, okay, RO software model, here's the water quality I'm going to send to my RO. What is my permeate or my treated water quality going to be? And what is my reject or my concentrate going to be? Because what you're doing is you're taking the contaminants and you're concentrating them, you're kind of squeezing them down into, you know, this liquid concentrated reject stream, right? And so you can get a nice output there, right? And you can look at multiple items, right? It's going to give us an output on all of the main cations, anions that we're looking at. But you do need that data to plug in. And then it'll also kind of tell us what compounds are, you know, inhibiting our recovery rate. So, you know, can we get 80% of the water through the membrane, or 90% or 70%? You know, how much of that water is going to go through and how much is going to go into the reject? And what's the limiting compound in that calculation? So, yeah. Okay, and I think this is my last slide here. So just a couple recent projects and examples of work that we've done. And I think this covers kind of the three of the main areas. So the first one in the upper left is, and apologies, there's not more details, but as you'd expect, all of these are highly confidential, folks very concerned and very, in very sensitive situations. So first one, kind of a fire cleanup project here. They're looking at PFAS and PFOA, and pretty high concentrations, right, on their influent. This one is a project we've deployed. These are field scale results. This is an operating system. It's been in operation for about 6 months, and will continue into the future here. There's another one here, industrial PFAS manufacturing. So this is looking at really like groundwater in the kind of area surrounding the manufacturing plant. This is some work that we've done on pilot scale, and they're working on scaling up now. And the last one here is some work on process water. This was a military facility here. We were looking at a number of wastewaters within the facility, and one of them was a chrome plating process. And as expected, as you can see with California Water Board, right, they've identified that you have PFAS in these chrome plating processes. That was really the only spot where we saw a hit as well in that facility. Here we actually weren't doing any sort of just process-wise here. This was membrane, carbon, ion exchange. Here we were looking at membrane and ozone, I think, options. And then down here, this was really just precipitation chemistry, focused on the chromium compounds. So a little different than the other ones we talked about. So this was not a maybe as expected of a result, but that was something that, again, depending on the chemistry in the water, you can see these things come out in other ways sometimes than through maybe some of the more conventional removal methods. So, and then just some examples of photos of what some of these different wastes have looked like. I think this one goes up here and this one up here. So here we go. I think that's a good solid 40 minutes, and maybe leave it there open for some Q&A. And I don't know, an hour is too long for anyone's attention in my mind, so kind of keep it there.
Yeah, so if anyone has any questions, please feel free to type it in the chat, or if you'd like to unmute yourself, you're more than welcome to do so right now, to ask TJ any questions in regards to this topic. Let me see here in the chat if anything new comes in. I guess while we're waiting for any questions, now your experience and how long have you been with water tectonics altogether, TJ? I think you mentioned that on the last
12
call.
years. Yeah.
Wow, 12 years, okay.
Yeah.
And then also just a quick reminder, TJ had mentioned it in the very beginning, but this call that we've done today and the last one that he did will be on YouTube. The first one's already up there on our Forge YouTube page, or also on our Forge website. It'll be up there as well for anyone to access for free. Does it look like any other questions are coming through?
Yeah.
So I guess.
Yeah, if anyone thinks of anything, my contact info will be on the site, or just reach out to me on LinkedIn or wherever. And thanks for joining. So.
Well, thank you, TJ. I really appreciate your time. You did fantastic on these two presentations. It's really caught my eye. So I guess with that, just thank you so much for everyone who decided to participate. We do have a quick question. So it's the YouTube channel. It's called Forge. I'll link it here for anyone who'd like to go check it out. Let me grab that link real fast. That is a good question, because it might be more difficult to find on your own when typing it in.
John, I don't know the answer to your question there. Is PFAS on any 303D lists, or are we expecting TMDLs? Like I said, as far as I've seen, the places where we are working, let's see, the 3 sites I can think that I'm working on right now. One, there's no specific regulation that they're being held to. They're kind of being proactive. They know there's concerns about these compounds and they are trying to get in front of it. They don't know what rulemaking may come down or where it may come from. The second site is in a legal situation. I assume there's some sort of consent decree agreement with the third party or something like that around the cleanup that's driving that action. And the third one is a case by case. It's really just the water board in this state that's directly involved, and you know, in a known contamination situation, working to do the cleanup. So again, yeah, in terms of broader rulemaking that may come down and how that may play out, I don't know. So yeah.
Awesome. So I just put in the link there for our Forge YouTube channel. We also have a website as well. But all these videos from Stormwater Awareness Week will be posted on there. You know, it's free education. That's one of the biggest parts about this, is that people can access this information for free. So we really appreciate everyone's attendance. Thank you so much, TJ, for your time again. And we look forward to the rest of the Zoom calls there this week. So thanks again, everybody.
Thanks, everyone. Have a good day. Bye.